Welcome to SQJ video. In this video, we are going to study Newton's second law of motion. Before that, let us study what is linear momentum. Linear momentum is product of mass and velocity of an object, which is denoted by P. It is a vector quantity, which means it has both magnitude as well as direction. You can see on your screen the units for momentum. This is a new concept introduced in physics for you this year. Now let us understand what is change in momentum. If an object is moving and we apply force in the same direction of the motion, the velocity increases. It means it change. So how to find change in that momentum? So change in momentum is denoted by a triangle called delta. As you can see the formula for it. Now as the velocity increases, the mass remains constant. The velocity might change to decreasing or increasing factor. Now let us understand what is rate of change of momentum by considering an example. Now here an object has mass m and initial velocity v. When a force is applied for time t, its velocity changes to v. So our initial momentum will be p1, that is m into u, and final momentum will be p2, m into v. Now for rate of change of momentum for time t, our formula will be change of momentum upon time. That is difference between the final momentum and initial momentum. So we will write P2 minus P1 upon T. Whenever we are talking about rate, it is always with respect to time. Now let's move ahead. Now we will substitute our value of P2 and P1 in the equation. Here m is common, so we will take m outside and in the bracket we will have v minus u upon t. So does this formula look similar somewhere? Correct, it is of acceleration. So we are going to substitute in place of v minus u upon t a. A is for acceleration. Change of velocity with respect to time. So now what we are getting is rate of change in the momentum for time t is m into a. So now this is only possible when your mass is constant. So because of force your mass doesn't change, then only this formula is true. So the rate of change in momentum of a body is equal to product of mass and acceleration. But we have one condition, that mass remains constant. Now as we saw, we got rate of change in momentum as ma. We also know that force is equal to ma. Thus force is equal to rate of change in momentum, which gives us our Newton's second law of motion. So as you can see on the screen, this is the statement for Newton's second law of motion. Now this is applicable in our day-to-day life, so we can think of many examples. So thank you for watching. Also you can watch the previous video on Newton's first law of motion. Next video will be on Newton's second law of motion. So hit the bell icon for notification.